Hey everyone! Today, we're diving into a groundbreaking discovery in the world of physics. Researchers have created an extremely exotic state of matter where atoms have a diameter 100 times larger than usual. We're talking about time crystals, an idea originally proposed by Nobel laureate Frank Wilczek in 2012. These have now been successfully created using Rydberg atoms and laser light at Tsinghua University in China, with theoretical support from TU Wien in Austria. Let's break down what this means and why it's so exciting. Welcome to Trendstorm. Chapter 1. What is a time crystal? Traditionally, crystals are arrangements of atoms that repeat themselves in space at regular intervals, creating a structure that looks the same at every point. In 2012, Nobel Prize winner Frank Wilczek posed an intriguing question. Could there be a type of crystal that repeats itself not in space, but in time? This would mean an object displaying periodic rhythms spontaneously, without any external stimulus, a phenomenon known as spontaneous symmetry breaking. Chapter 2. Controversial concept. For years, the idea of time crystals was controversial. Some believed they were impossible, while others searched for ways to create them under special conditions. Now, researchers at Tsinghua University, with support from TU Wien, have successfully created a spectacular kind of time crystal. The results of this groundbreaking work have been published in the journal Nature Physics. Chapter 3. The experiment. The key to this discovery lies in using laser light and Rydberg atoms. Rydberg atoms are special because their electrons orbit the nucleus at distances several hundred times larger than normal. This makes the atoms gigantic compared to the usual size. Here's how the experiment worked. 1. Setup. Laser light was shone into a glass container filled with a gas of rubidium atoms. 2. Measurement. The strength of the light signal that arrived at the other end of the container was measured. 3. Observation. Despite the laser beam having a constant intensity and no specific rhythm imposed on the system, the intensity of the light began to oscillate in highly regular patterns. Chapter 4. Spontaneous symmetry breaking. This phenomenon, where a periodic rhythm emerges spontaneously, is known as spontaneous symmetry breaking. Professor Thomas Pohl from the Institute of Theoretical Physics at TU Wien explains that the tick frequency is predetermined by the physical properties of the system, but the times at which the ticks occur are completely random. Chapter 5. Giant atoms and their role. The experiment's success hinged on preparing the atoms in a special way. By adding energy to the outermost electron of an atom, its distance from the nucleus can become very large, creating Rydberg atoms with giant electron shells. When these atoms are in such Rydberg states, the forces between them become very large, changing the way they interact with the laser. When the laser light is chosen to excite two different Rydberg states in each atom at the same time, a feedback loop is generated. This causes spontaneous oscillations between the two atomic states, leading to oscillating light absorption. Essentially, the giant atoms stumble into a regular beat, translating into the rhythm of the light intensity. Chapter 6. Future implications. This new system provides a powerful platform for deepening our understanding of the time crystal phenomenon. Precise, self-sustained oscillations could be used for sensors, among other applications. Giant atoms with Rydberg states have already been used successfully in other contexts, suggesting a bright future for practical uses of this discovery. The creation of time crystals using Rydberg atoms and laser light is a fascinating step forward in physics, bringing us closer to Frank Wilczek's original idea. This breakthrough could have significant implications for future technologies and our understanding of the universe. Source: Vienna University of Technology. If you found this topic as fascinating as I did, don't forget to hit that like button, subscribe for more updates on the latest scientific discoveries, and let us know in the comments what you think about this new state of matter. Thanks for watching, and see you in the next video.